going to look at the next idea for this lesson, solving equations by factoring. The good news is I think the first part is much harder than the second part, so hopefully this part will be a little bit easier. And we've got this thing called a zero product property. You guys know what the zero product property is. Anything times zero is zero. As long as one number is zero that's being multiplied, you're always going to get zero. So our zero product property says if a product of two factors is zero, then at least one of the factors must be zero. Look right here, this is what it's saying. If a times b equals 0, then we've got one of three things must be true. Either a must be 0, if b were something else, so like a is 0, b is 100, this would still be 0. Or b is 0, so let's say a is 100, if b is 0, this is still 0. Or obviously, they both could be 0. One of these three things has to be true, which will help us solve equations by factoring. And when we solve by factoring, we're looking for a solution or root. So if I say find the roots of an equation, you're just solving it and finding which ones make it true when it equals 0. Okay, so to solve each equation, what we're going to do, we're going to factor it, and then we're going to solve it from there. So notice, this is factored, 2d plus 6 times the quantity of 3d minus 15. And notice, I'm multiplying these two pieces together, and they equal 0, which means either the blue piece is going to be 0, because 0 times whatever this green piece is would be 0, or the green piece is going to be 0. Because then, if this is 0, it doesn't matter what the blue part is, the whole thing would be 0, because anything times 0 is 0. Or obviously, they both could be 0, but you don't really need to worry about that. So what I'm going to do, I'm going to set each of these individual pieces equal to 0, because I'm saying one of these has to be 0 in order for this to be true. So I'm going to solve this, subtract 6 from each side, I get 2d equals negative 6, divide each side by 2, d equals negative 3. So there's one of my roots, negative 3. When d is negative 3, we get 0. To find my other root, I solve my other equation. I get 3d equals 15. Divide each side by 3. I get d equals 5. And that's the other part. So to solve each equation, I get d equals negative 3, d equals 5. To check my solutions, I plug them in. 2 times negative 3 is negative 6. Negative 6 plus 6 is 0. 0 times whatever this is would be 0. Plug in 5. 3 times 5 is 15. 15 minus 15 is 0. I don't even care what this blue part is when I plug in 5, because I know whatever it is times 0 would be 0. So all you do, you factor, and since we're multiplying these two together, if one of them is 0, the whole thing is 0. Now part B is a little trickier, but all you have to do is try to get one side to equal 0. So I'd get c squared minus 3c equals 0. Now that I've got it equal to 0, I can solve it once it's factored. Notice c squared and 3c, they each have a c in them. So I get c minus 3 when I factor out that c, because c times c is c squared, c times 3 is 3c, equals 0. And now, just like in the first part, I've got two separate pieces that could be 0 in order for this whole thing to be 0. First one, pretty easy to solve. C equals 0. Second one, not much harder. Add 3 to each side. C equals 3. So what are our solutions here? Either 0 or 3. And notice, if I plug in 0, 0 equals 0. That's good. Plug in 3. 3 squared is 9 equals 3 times 3, which is 9. These are our solutions. They both work when we plug them in. Big idea, once you get it factored, and I'm going to circle each one where it's factored. This one's factored right there. This one's factored right there. Once you have them factored, you just set each piece equal to 0 and solve from there to find your answers, which we also call solutions or roots.